Hey guys, so today I'm going to talk about my heat treat process for my knives, and this is just for basic carbon steels. So essentially you're heating them up to critical temp and quenching them in oil. This is a very rudimentary method. It's not super precise. I'm actually currently in the process of buying an evenheat kiln to do this with, but for the sake of the video, this is how I do them at the moment, and it still works. So I'm using some canola oil in this video. Something like Parks 50 or AAA would be a better quenchant oil, but it still does the same, still works the same. So I'm using canola in this video, and I'm just filling it up in an old ammo can to use as my container for my quenchant. And I'm filling up past, and this is my big buoy that I'm doing right here. So to heat up all my knives, I use a propane forge, and I have fire bricks that I use set up to sort of act as doors to help insulate it and heat up the best areas I need. And I'm putting in just a little scrap piece of steel right here to go ahead and heat up in my forge, and I can use that to just go ahead and preheat my oil. You want to go ahead and preheat your oil because it creates a less drastic change in temperature from hot to cold. So that's what I'm doing here. I'm just dunking some warm steel. By warm, I mean several hundred degrees steel into the oil, and just go ahead and heat up the oil. So that's what I'm doing right now. And canola oil has a rather low flash point, as you can see. So certain oils like olive oil have a higher flash point. So that's something to take into account when you're using it. But like I said, something like Parks 50 or AAA is a better solution. So here you can see inside my forge, and I have two pieces of angle iron with 1/4 inch bolts in it, and I use that as just a little stand to elevate my knife in there so that I get a good overall heat on the knife, and it holds it up high enough and keeps it steady inside there. It's a nice little work rest I made. And now I have my fire bricks closer together to keep most of the heat in there, and this is the waiting game essentially. You sort of want to watch color, and you can use a magnet to test after a certain amount of time, so you can pretty much tell by color when it's ready. But when you're starting out, heat it up to past non-magnetic, where the magnet won't stick to steel anymore, and then a little longer. And that's a pretty good general rule of thumb. But like I said, I'm in the process of getting an even heat kiln where I can program what temperatures it needs to go to, how long it needs to soak, etc. But for certain basic carbon steels like 1095, 1084, W2, 01, 1070, these kinds of steels, this kind of heat treat works really well for them. You can get a real hard, good edge with this kind of heat treat. So don't let the lack of expensive or sophisticated kilns to do this heat treat process or to keep you from making knives. And there's also companies that will heat treat for you. But like I said, this process is crude, but it's still effective. Okay, so now I'm ready for the quench, and you don't want to do what I just did. Invest in some good gloves and really try to stay away from those flames. It got real hot and I dropped it for a second. It sat on its side, and that's actually what caused it to warp, as you'll see later on. So don't do that. What you want to do is this. You want to keep it controlled, keep it steady in the oil, make sure everything's even on it. It's not sitting sideways, but going in up and down and not side by side. So you want to do something more like this kind of quench. Very controlled. You don't need to harden the handle area. There's no need for it, and it just makes it more likely to break in the handle, so I don't harden it. And then you just keep it nice and controlled, and then go down and then cool the handle after the initial quench of the blade. And then now I'm just doing a file check for hardness, see if it's harder than a file. If the file skates over it, then the steel's harder than the file. And that's a good general rule of thumb just for if your blade's hard enough to make a good edge. So that's just a quick and easy little check to see if it hardened, and you can see it skates over. Now you can see my buoy. I'm looking at showing you guys how it warped. I had it on the side. So warps are never fun to deal with, and you can see right in here I'm trying to fix that warp. Or more like I'm showing it to you. I'm going to have to fix that though. And in the next little clip I'm going to show you how I fix my warps. what I usually do is I get a big piece of like 3/8 inch bar stock, and I'll go ahead and clamp the blade down to it. You can use things like washers or any kind of little metal shims to put down in between it, and then you're going to clamp it down to it. And this is my favorite method. Some people will take a vise and use 3 pins and sort of alternate to try and pull out warps. I've done that in the past. I've also broken blades in this process, which is quite heartbreaking. So you can see there's a pretty significant warp there. So what I'll do is I'll use some little washers or something and put them in between that 3/8 inch bar stock and then between the blade, and then I'll clamp it down and it will pull that warp out. And what you do is you'll keep it clamped like this through your temper cycles, so then when you come out of temper, your warp will be gone and you'll straighten the blade out. So invest in a bunch of these little C-clamps. They're really great for different processes like working your handle or when you're hand sanding, and for pulling out warps they're really great. So I recommend those. You can see that's how much I have to pull out. So I'll use some larger C-clamps to pull out the rest of this warp. And here you can see now that I have some larger C-clamps. I'm going to use that to pull out different areas of the warp. Like I said, you can use washers. People use aluminum cans cut up into little shims, anything like that. And now, when it comes to tempering, you can use pretty much any kind of oven. My buoy is so big that I'm actually putting it in a regular kitchen oven, and that works just fine. I recommend just go ahead and clean the knife real good in the sink with some soap and everything, just to prevent any kind of chemicals or anything that's on that blade from going into your oven that you cook with. So just keep that in mind. Just be safe with that kind of stuff. And I have this set at 400 degrees, and I do 2-hour cycles. So I'll heat it up for 2 hours to 400, let it cool down to room temperature, and then do it again. And that's what's going on here. And then also for little knives, I'll go ahead and I'll just use something like a toaster oven. That's a lot cheaper as far as electricity bills to run. And for smaller stuff, it's real simple. It's not as precise. But like I said, this kind of stuff works. But like I'm working on getting an evenheat kiln, and that's very precise down to the plus or minus degrees Fahrenheit. So overall, that's the best option. But this stuff works and it's doable. And here you can see I'm taking it out in its little jig that's clamped up in. And this is after the first temper cycle. So I'm going to have to adjust the clamps a little bit to really pull out the rest of the warp. But for the most part, this is what I do to pull out warps. It works the best. But this is really a process that makes a knife from a piece of metal, takes it from a piece of metal to a knife as a heat treat. It's probably the most important process. And it can be done with just some of the basic tools. You could do that with charcoal and a hair dryer. And that's the way I did it before I got that propane stove, or that propane forge. And like I said, eventually, or I'm currently in the process of trying to purchase an evenheat kiln. They're rather expensive, but they are worth their money, especially if you want to move on to like stainless steels or more advanced tool steels like D2, M4, A2, those kinds of steels. So you can see I'm moving around now and trying to straighten up the rest of the warp on there. And then once it cools down, I go ahead and put it in for another temper cycle, and then it should be straightened out. Alright, so that's how I do my heat treat for my knives. Thanks for watching, and like and subscribe. If you have any questions or anything or suggestions, just go ahead and toss them down in the comment section. Thanks, guys.